Okay, in this video we're going to talk about how to actually find an exponential function. In the previous video we talked about there's two different ways that you can write an exponential function as a number times e to the kt or as a number times b to the t. I want to start off by talking about the significance of this number up front, the y0. It turns out this is always going to be your starting amount. Which a lot of times is going to be your initial population or the initial amount before stuff starts to grow. The other way to think about this starting amount is it's actually going to be the amount at time t equals 0. And so if time t equals 0 makes y equal to y0, that means that our point is going to be time 0, y0. And so this number y0 is actually going to be the y-intercept. And I'm not going to go into all of the details of why this is true, but in either one of these equations, if you plug in 0 for t, b to the 0 is actually just going to give you the number 1, and so your answer is just going to be y0. That's kind of the reason behind it. So I want to start off by looking at an example. An account grows from $1,000 to $1,261 in 8 years, and we're going to try and find an equation for that, and we're actually going to try it two different ways. One is assuming it's a straight line, meaning a linear function, mx plus b, and one is using an exponential function like this. And I want to try and compare the two. That's the reason I'm doing both ways. So let's start off with the linear function. If we're given two pieces of information, a dollar amount at one time and a dollar amount at another time, I can think about that as giving me an x and a y. So let's see, x is probably going to be my time, and y is going to be my number of dollars. And so at time 0, we have $1,000. At time 8, we have $1,261. And we've talked before about the way you would find the slope, but I'm going to go in a little bit different order so that it looks, so that I can talk about some comparisons between the two methods. So first of all, this point here, x is 0, y is 1,000, that's actually the y-intercept, and so that's actually going to be our b. We've talked before that the y-intercept of a straight line is the number b. And so right off the bat, we know one of the two constants. We know b. We don't know m yet. And if I rewrite the equation, this is now y equals mx plus 1,000. If I plug in the second piece of information, which is an x and a y, I can stick the 8 in for x and the 1261 in for y. And now I have an equation that only has one unknown, one variable, which is the number m. And so we can solve for m this way. So I guess we would subtract 1,000 both ways, or from both sides. And you get 261 is equal to 8 times the number m. And then divide both sides by 8. I'm going to do that on my calculator. I get 32.625. And so now that we know m, we plug it back in and we say f of x is equal to 32.625 times x plus b, which was 1,000. So that's our linear equation. Okay, now we want to look at an exponential equation. So again, we have two pieces of information, a dollar amount at two different times. So this time I'm using t as my variable instead of x. Doesn't really matter though, I could still use x if I wanted to. The only thing that makes this exponential is that your variable is in the exponent. We have the exact same set of points. And again, we have a y-intercept. Which we said the y-intercept of an exponential is your starting amount, and so that's always going to be your y0. So it's a little bit different here. Before b was the y-intercept, now b is specifically the number that is not the y-intercept. So be a little careful with that. Okay, So our y-intercept is y naught in this case, so f of t is going to be 1000 times b to the t. And then we have another piece of information. If I plug in this other piece of information, t is 8 and y is 1261, so f of t is 1261. And then b to the t would be b to the 8th. And so now we just have to solve for the number b. And be careful of your order of operations. Remember, we do exponents before we do multiplication. So I want to work from the outside in. First thing I should do is get rid of that 1000 by dividing both sides. The opposite of multiplication would be division. And 1261 divided by 1000 would be 1.261. And conveniently, this is another equation that we've seen before. If we know an exponent, a power of b, and we want to know b by itself, we just take a root of both sides. So I'm going to take an 8th root of both sides so that my 8th power cancels out. And again, I'm going to type this in a calculator. Let's see. We've talked about this before. An 8th root is actually a 1/8 power, so I can type it in that way into a calculator. So let me pull my calculator over here real quick. Okay, so we want to type in 1.261 and then exponent, and probably wouldn't hurt to put 1/8 in parentheses just to make sure that whole thing goes in the exponent. And hopefully you can see this 1.261 to the 1/8 power ends up being 1.029. Okay, so we now know y0 and b, so we can plug these into our equation to get an exponential function. F of t is equal to y0 times b to the t, 1.029 to the t. And I can probably leave it like this, but if I wanted to make sure I don't make any order of operations mistakes, again, remember, the exponent would happen first, so our parentheses should probably go there. So I don't want to accidentally multiply 1000 times 1.029. Okay, so that was kind of my point for doing this both ways, just to show you that in both cases, if we know the y-intercept, that tells us one of the constants, is just which one is a little different. And we have some other piece of information, we plug that in and then solve the equation for the other constant. And so by that two-step method, using a constant, using the y-intercept to find one constant and then plugging stuff in to find the other constant, we end up solving for both constants.